we are still on projectile motion, and of course we have done little on this part before, and we want to further illustrate the motion of a projectile. We want to further explain the motion of a projectile. Remember I told you that any object launched or thrown or propelled into the air is known as a projectile. And we also said that the study of a projectile motion is known as ballistics. The path of a projectile is quite curved, and the curved path takes the shape of a parabola. And therefore, the path is said to be parabolic. The path of a projectile is a trajectory. And we also said that the flight of a projectile is divided into two motions, the vertical motion and the horizontal motion. If you examine the motion of a projectile very well, there is one force. It means that there is only one force acting on it, which is the force of gravity. And the direction of the gravity is usually downward, and it has no horizontal acceleration except vertical acceleration. You can see with what we have on the board, the graph we have on the board, there is angle of projection, which is the theta, and we have the initial velocity. And don't forget that a projectile is usually projected with an initial velocity, which is u. You can see the body is at this point here, which is at rest. The acceleration here is 0. The acceleration at this very point here is 0. It means I can see my A is equal 0. The acceleration at this position is 0. Now this body now, I want to throw it from this position to this very position. Meaning if this body leaves this position for this position, it means that we now have final velocity. This one becomes initial, because when it was at rest we have initial, but at this point here it becomes final. Therefore the V will now be different, which is the final velocity. No longer initial, become final. Now we have also the angle. You can see at this position the angle of projection is theta, but when we come to this position here we have the angle alpha, which is quite different from this one. It means that the angle of projection here is quite different from the angle of projection here. It means that when the body is projected to this position here, you know that at the end you are going to still project it from here to this position. It means that the angle at this position is quite different from the angle it will be projected at this position. Therefore, you can see I differentiate the angle. Yes, theta is alpha. Okay, now do you know that this body will still leave here and come to this position, and this one here, this position is the highest height that this body can attain, which is this projectile can attain. Therefore, we have the maximum, at this point we have the maximum height. We have the maximum height. And we use h to represent that maximum height. Okay? Now, this very body will definitely move to this plane. This is the plane of projection. This is the plane of projection. Okay? And of course, when this body comes down to this position here, we have the range. Therefore, at this point here, to this one here, we have the range. This position here is the range. This position here is the range. If we take note, this position here is the range. Okay? This one is the range. And of course, we can also call that range maximum horizontal displacement. Maximum horizontal displacement. Therefore, I can call here maximum horizontal displacement. Maximum horizontal displacement. That is the very position here. Maximum horizontal displacement. Okay. Now, in this very one here, remember here is the horizontal displacement, and this one is the vertical displacement. This very one here is called the vertical displacement. Okay, that is why. Now you can see that this U will have effect here. This U will have effect here. It will also have effect here. Please take note. This U will have effect here. It will also have effect here. The same thing applies to this V. At this position, this V will have effect. It will also have effect here. Now, what will see the effect that this U will have in this direction? We also have in this direction. Now we are going to be using right angle triangle to explain this very thing. Okay, this very part here. Okay, now to do that, let us see what will happen. It means I want to bring this very part out like this. This is what I have. I have here, which is the Y. I have here, which is the X. Okay, this very part here, I have it as U. Okay, this very very one here is u. Okay, we have here as u. Okay, which is the initial. Okay, now do you know that I can as well trace this part? I can trace it. I will have here. Remember that here is y, which is the vertical displacement. Y here is the horizontal displacement. Look at it here, horizontal displacement, vertical displacement. Therefore, I will have it as x. Okay, now if here is y, here will also be y because you can see it's vertical. Therefore, here will also be y. Okay, and here is already x. Now, you see the angle of projection because the body was here. The angle of projection is theta. Now, I can bring this part now. If I bring it out, I will have something like this. I'm going to have something like this. I will have a right angle triangle. I'm going to have something like this. This is what I will have. I will have something like this. Here is y. Here is the angle of projection, and here is u, and here is x. Therefore, we have right angle triangle. Do you know that in right angle triangle, there are two things we use to resolve it? There are two ways to resolve right angle triangle. Either you use SOHCAHTOA. Okay, we have done trigonometry before in mathematics. Either you use SOHCAHTOA or you use Pythagoras theorem. But in this very case, we are not using Pythagoras theorem in this very case. We are going to use SOHCAHTOA because there's an angle. We are dealing with angle. If you are dealing with the case of sides, if you are dealing with sides, we use Pythagoras theorem. But now that we have angle, we have to use SOHCAHTOA. Now, from what we have here, we want to determine this very part here. We want to see what we can have here, this very part here. Okay? Looking at this very one, remember this one have effect on this part. It becomes what? Opposite over hypotenuse. This longest direction, this longest side here, the longest side here, it is known as the hypotenuse. Okay? While here is now adjacent. This angle here is facing this position here, this direction here. Here become opposite. This one is adjacent. Become opposite over hypotenuse. Therefore, it becomes sine. Sine theta equal u all over. Okay, sorry. We are going to have sine theta. Okay, let me put it this way. We are going to have sine theta equal. I think okay, we have y there. Y all over u. Okay, now we can make this one over 1 cross multiply. If I cross multiply, we have I'm going to have y equal u sine theta. Okay, it means that for this part here now, for the y, I'm going to have u. It means that the effect here will be u sine theta. Okay, that is what we have there. That's the effect there. Okay, let us see the effect on this very part here, which is the s. Now, since I'm not dealing with y, I want to deal with the s. Here become adjacent. Here is the adjacent. Here was opposite before. Here become adjacent over hypotenuse. Therefore, adjacent over hypotenuse from what we have here is car. Look at it. The former one was so, like the one I did before. So opposite over hypotenuse. This one is what? Adjacent over hypotenuse. Therefore, I will have cos theta equal, and what we have there, we have x, which is adjacent over hypotenuse. And what is the hypotenuse there? U. Now, if you cross multiply, you make this one over 1. Therefore, we're going to have s, which is u cos theta. Therefore, at this position here, we have u cos theta. You take note for this horizontal displacement, we have u cos theta. While for this y, vertical displacement, we have u sin theta. And therefore, this initial velocity will have effect here, will also have effect here. The same thing applies to this one. If I also do this one, the same way I will also do this very part. Therefore, this one becomes v cos alpha, while this one becomes v sin alpha. Okay, I think with these we are okay. Now, please don't forget that when this body moves from here to this position, this very position, the highest, it's going to get to this highest height. And the vertical velocity there is 0. Look at it. The vertical velocity is what? 0. You can see Vy become equal 0. Okay, and for this one, when the body was here, because it was thrown from this position to this very one, I told you that there is one thing that you need to examine. I mean, there is one thing you need to know about this motion, and there is an acceleration. I said that at this point acceleration is 0, but for this one we have a vertical acceleration, and it's usually downward, and it's minus g. At this point we have minus g. It means that when the body was here at rest, we have a equals 0, which is initial. Now coming to this position, now we have acceleration equal minus g, which is downward. Remember the two direction, which is the y and the s. You know, in your cardinal points, we have here as the origin, and here is plus. When the arrow is pointing to the right, it's addition. When it's pointing to the left, it's minus, like for the s. While when it's pointing upwards, we have positive, which is plus. When it's now pointing downward, we have minus. Of course, this one is for y, while this one is for x. Now, coming to this very one here, you can see the arrow is pointing downward. Therefore, our acceleration is minus g. Okay, with this one explanation, we can stop here so that in our next class, we are going to look at the motion along the y components, and also the motion along the s component, that is the s direction. Okay, this one is going to be this very discussion, which of course the one that has to do with motion on the y component and also the motion on the s component. We are going to look at that in our next line of discussion. Thank you for joining me on this very part, and of course on this platform. And don't forget to join me again in this very section of projectile motion. We are not done with this very section. We are not done with this very section, projectile motion. We are still on this very part. In our next discussion, we are going to continue, and we are going to look at motion on y component, which is the y houses, and also motion on the s component, which is the s houses. And that one will be our next discussion. Please try and join me on this platform, and don't forget to like my page, GB Jumbo Online Mathematics. And of course, go to my YouTube channel, subscribe to my YouTube channel, and of course, Mathematics Mega Science, the Mathematics Science Mega Tutorial. Please don't forget to subscribe. Mathematics Science Mega Tutorial. That is my YouTube name. Mathematics Science Mega Tutorial. When you get to the YouTube, the app, just type Mathematics Science Mega Tutorial. You can see that the platform will appear. Just subscribe to the platform so that at the end we always get notification. And also for the Facebook page, see, go there, search, and type type GB Jumbo Online Mathematics on that very page. Your Facebook, type GB Jumbo Online Mathematics, and you will definitely have the platform. And of course, like the page, and you also get notification. Okay, I can see all the best here. God bless you.